Okay, welcome to Success Math 120 class. And we have some questions on the board. Class, these are the kind of tough questions you expected to see in the exam. Class, nobody will ask you to differentiate 2x raised to power 5. This is too simple. This is just basic simple differentiation where you have your coefficients, you have your base, and you have your power. This is just simple differentiation where you have your coefficient. In case you're just new here, that means you don't even know this. This is the simplest form they can ever ask, which will not come out in the exam. It's too simple. Class, in this one, you have what we call your coefficients. Your coefficient is the number before x. The number before what? X is called your base. And 5 is your power. Anytime you want to differentiate, you have coefficients. The number that comes before x is called your coefficient. X is called your base. And 5 is called your power. So when you want to differentiate, you have to multiply coefficient and power. The first step of differentiation, simple differentiation, which you should have known by now, but some people resume late. Multiply your coefficient and power. 2 times 5, you have 10. I hope this is showing. 2 times 5, you have 10. That's the first rule of differentiation. First step, multiply coefficient and. Step 2, repeat your base, x. Repeat your base what? Please follow carefully, follow carefully. This is not a course you joke with. And step 3, subtract 1 from the power, 5 minus 1. So class, the differentiation of 2x raised to power 5 is 10x raised to power 4. The differentiation of 2x raised to power 5 is 10x raised to power 4. So class, if you have a function y equals to 2x raised to power 5, then we'll say dy dx equals to 10x raised to power 4. Class, the symbol or the expression we use to represent derivative is called dy. We use dy dx to represent derivative or differentiation. Another name for differentiation is derivative. Another name for differentiation is derivative. So one more time, this coefficient, this base, this power. There are 3 steps when you want to differentiate these simple kind of questions. Multiply the coefficient and power. You say 2 times 5, 10. Bring down your base, x, and subtract 1 from the power. 5 minus 1, 4. If I want to differentiate 10x raised to power 4, I'll go again. In this time around, my 10 is my coefficient, x is the base, and 4 is the. Step 1, multiply coefficient and power. 10 times 4, 40. Repeat your base, x. Subtract 1 from the power, 3. 40x raised to power 3. Simple method of different. But class, someone has learned this now and thinks he's ready for exam. No. Class, imagine learning this and say, okay, now differentiate 2xy plus 4y raised to power 3 plus 3x squared y equals 7. Class, the way you differentiate x components is different from the way you differentiate y. Class, there's a big difference when they say y equals to 3x plus 5. Class, in this function, this is an explicit function. In this function, the components of y are clearly separated from the components of x. So if they say y equals to 3x plus 5, differentiate, you say dy dx, dy what? Equals. Differentiate 3x. 3x means 3x raised to power 1. So differentiate 3x raised to power 1. You say 3 times 1, 3. Bring down your x. Subtract 1 from the power. Your 1 minus 1, 0. Class, 5 is a constant. Differentiate 5, it disappears. Anytime you have a number that does not contain x and you have to differentiate it, the number it no longer exists. It no longer exists. So the final differentiation of 3x raised to power 1 plus 5 is 3x raised to power 0, which is 3, because x raised to power 0 is 1. Anything raised to power 0 is what? Any variable raised to power 0 is 1. So x raised to power 0 is, so 3 times 1, 3. But class, next time, you don't need to go through this long method. Anytime you say a number and x and you have to differentiate 3x, your answer is 3. Differentiate 5x, your answer is 5. Differentiate 10x, your answer is 10. Differentiate 20x, your answer is 20. Anytime you have a number with x, class, clean the x, take the number. Anytime you have a number with x, clean the x, take the number. Clean the x, take the number. Give me a new marker there. Clean marker. 2. Class, I know why I'm hammering on this simple foundation, because this foundation will help us in whatever we're doing here, though. But class, in this function, you see x and y existing in the same expression, 2xy. 4y raised to power 3, 3x squared, y equals to 7. Class, anytime you see a function where x and y are mixed up together in the same function, class, you are dealing with an implicit differentiation. You're going to apply what? Implicit what? So class, write down the first thing I'll teach you is implicit differentiation. Implicit implicits. Now class, pay close attention. Pay close attention. Class, in implicit differentiation, we're not just differentiating x, we're also differentiating y. Before now, if they are given a function y equals to 3x raised to power 5 plus 2x squared plus 5x plus 1, and you have to differentiate. Class, look at this function. There's no trace of y here. There's only one y in this side. And when you differentiate y, you have the y. Class, the first thing you should note is that the differentiation of a y component is the y dx. Anytime you differentiate a y component, you have the y. But look at this function. See that y is clearly separated from x. X is on this side, y is on this. This guy is more easy to differentiate because it doesn't need implicit. You just need to say 3 times 5, 15. Bring down your x. 5 minus 1, 4. Plus 2 times 2. Bring down your 2 minus 1. Plus differentiate 5x. What do you have? I told you, right? Anytime you have a number and x, clean the x, take the differentiate 1. 1 is a constant. A number that does not contain x disappears after differentiation. And therefore, the y dx is 15x raised to power 4 plus 4x raised to power 1 plus 5, and you are. But class, the same cannot be said of this. The same cannot be said of. In this one, see, x and y are mixing up together. X squared y cubed, x squared. Class, a separate approach is required when differentiating a y and x component together. A separate method is required when differentiating a y and x component together. And I'm about to teach you now, so pay close attention. Class, any of our tutorial we are doing now, if you miss it, you will miss something key, important exam topics. We have been joking since. I'm going to the technical aspect of each course now. The tougher aspect of each course. Class, how do you differentiate y components? Class, y is the same thing as dy dx. Dy what? What if it is now 2y? Class, differentiate y, you have dy. So differentiate 2y, you have 2 dy dx. 2 what? Differentiate y square. Y square is 2y dy dx. Differentiate 3y raised to power 4. It is 12y raised to power 3 dy. Who understands what I did? And who is lost? Nobody wants to be lost. Everybody say, no me go for my hand. I understand by God's grace. No me go for my. So everybody don't get that one. Only me. I know they raise up my hand. I know they agree. I know they. Don't worry, it's normal. Nothing to be ashamed of for now. Class. For y components, class, treat them as if you are treating an s component. But after doing it, you now put dy dx at the end. That's the difference. Class, let me remind you. Anytime you are differentiating a y component, assume it is an s component. So do it as you would do an x component. But at the end of it, you now put dy. Class, Class, if this was 2x, what would have been the differentiation of 2x? Is it not 2? Class, differentiate 2x, you have 2. But differentiate 2y, you also have 2. But at the end of it, you put the y. Class, for every the y component to differentiate under differentiation, always include the y dx. For every y component to differentiate during differentiation, include the y. Class, look at y square. If I have to differentiate x square, what will you have? Is it not 2x? Differentiate x square, is it not 2x? Because x square means 1x square. Do you agree? X square means 1x square, and 1 times 2, 2. Bring down your base x, subtract 1 from the power. 2 minus 1 is 2x raised to power. And 2x raised to power 1 is written as 2. So now differentiate y square. Assume it's x. 1 times 2, 2. Bring down your, subtract 1 from the power. What will remaining? 2y raised to power 1 is 2. Then include the y dx. Now look at this. 3y raised to power 4. Let me show you again. What if this was 3x raised to power 4, class? If I have to differentiate 3x raised to power 4, what will you have? 3 times 4. What happens to your x? Bring it. 4 minus 1. So, class, differentiate 3x raised to power 4. We have 12x raised to power 3. So, differentiate 3y raised to power 4. We have 12y raised to power 3. But add the y. So, the only difference between differentiating x and y components is that for y component, after differentiation, add the y. Making sense, class? So if you have to differentiate 2y raised to power 7. Differentiate 2y raised to power 7, what will you have? 14y raised to power 6 dy. Thank you. So for every y component that is differentiated, a dy dx is introduced. For every y component that is differentiated, a dy dx is what? Introduced. Class, are we following? This is mathematics supposed to be sweet. Many of you are teaching you like this in lecture. You will not have need for tutorial. But they don't teach it like, they don't break it down step by. They teach you as if you already know it before. Or you don't even teach at all, or the noise. Some of your problem is not even that you don't understand. You're not even hearing the lecturer first. How can you understand what you are not? You're not even hearing. How can you understand what you are not hearing? So let me even hear first, so that I will see if you understand or not. That's the challenge. Many people are not even hearing. I've been in lecture with people at the back. I was in college or which day? People were at the back. They were just pressing their phone. I said, what's going on, sir? If we follow this man, we'll not understand anything. When they come class, they are not understanding anything. We are coming for tutorial, sir. We are not understanding this man. He was using red pen that is very faint.